Alright, classic stuff here. It's a nice little 25-minute problem. Editorial note, I feel like these are a smidge too easy. They're good. They're really good practice. I feel like they're just a smidge too easy to compare to what you're going to see. So anyway, they give you a chance to do some chain rule stuff here. So p prime of x equals f prime of x times g of x plus f of x times g prime of x equals -1 times 3 plus 3 times 9. By the way, I screwed this one up, so don't do that. Don't screw it up. It's a little too easy to screw up. This is actually kind of nice. They say, hey, find p of 1, and you're like, well, I don't know what p of 1 is. Like, yeah, well, it's f of 1 times g of 1, 9. So the point you have there is 1 comma 9. So now it's just y minus 9 equals 24. X minus 1. I like to move it over. Sorry for the sloppy. And then, of course, they're going to do that. They do quotient rule. They got me with this because they got this little normal thing here, so you have to do the flippy floppy thing with the slope. So q prime of x equals g of x f prime of x minus f of x g prime of x g of x quantity squared and g prime of q prime of 2. I think I want. Yeah, sloppy on my notation, such as life. Q prime at 2 equals 1 times 3 minus 0 times -2 over 1, which is 3, and then q of 2 is 0. So the point is 2 comma 0. So y equals, because it's y minus 0, this is what I talked about. Don't be in a rush. Stop, read the question, catch your breath, underline things. X minus 2. And then they're going to do a little chain rule. Of course they are. So c prime of x, excuse me, OCD kicking in with the change of colors. C prime of x equals f prime of g of x times g prime of x. G of 1 is 3. So this becomes f prime of 3 times g prime of 1, which is 1 times 9. They didn't ask for anything flashy, so didn't have to put it in a point slope form, didn't have to jump off a bridge with it, all that sort of stuff. Second degree polynomial. So you should be getting pretty good at this. P2 centered at x equals 0 is f of 0 for f plus f prime of 0 x plus f double prime of 0 x squared over 2. I believe you just plug them in and you're pretty much good to go. So p2 of x equals 4 plus 3x plus the 2's cancel, x squared. So find a polynomial, now find approximation. P2 of 0.2 equals 4 plus 3 times 0.2 plus 0.2 squared equals 4.64. And last but certainly not least, if the third derivative of g at 3 equals 12, find the polynomial centered x equals 3, third degree. Now this actually I could see as a question. P3 of 3 equals g of 3 plus g prime of 3 times x minus 3 plus g double prime of 3 x minus 3 squared over 2 factorial plus g third derivative of 3 x minus 3 to the third over 3 factorial. Blast that out and do some canceling. You should get 5 plus 7 times x minus 3 plus x minus 3 squared over nothing. The 2's cancel. And by the way, I'd just like to say, I think these problems are really well put together. I don't remember the individual's name who did this on the College Board blog, but God bless him. My only complaint is they would get into something about alternating series here, because they always do. So I'm a little surprised they didn't have that on this problem. It's hard to build it in. He built these from scratch. So, all right, now a real number 6 problem, which is always nice for those who are into wanting to kill themselves. No, that was wrong. Didn't mean to say that. So they say write third degree polynomial for f, and like I said, we should be getting pretty good at this. About x equals 0. F of 0, f prime of 0, x, f double prime, and it says third degree polynomial. So let's not make the same mistake I just made. Plus f 1, 2, 3 of 0, x to the third over 3 factorial. Plug it in and do the canceling. Equals 3 minus 2x plus 3 halves x squared minus 23 over 12 x to the third. Alright, rolling along as the lawnmowers start to kick in the neighbor's yard. Can almost always count on that when I'm making a video. B, write the first 3 zero terms of e to the x, first 3 non-zero. 1 plus x squared over 2 factorial, which is basically just 2. And then find the second degree polynomial of e to the x times f of x. So I don't need all 4 terms. E to the x times f of x equals 1 plus x squared over 2. 3 minus 2x minus 3 half x squared. Getting a little busy there. I actually do it like this. I've seen this kind of problem often. And then the next term, 3x minus 3 half. Nope. X minus 2x squared, and then plus 3 halves. That's wrong. It should be positive up here. It should be positive here. Plus 3 halves x squared. And I line them up so I can add them, and I get 3 plus x squared. If you're like me, you're probably like, oh, that can't be the answer. That looks too easy. It's got to be fractions. And no, that's it. Just, have a little faith. And then C, they want the integral. And they want it the integral of part A. So we got this part B is kind of hanging out in the middle of nowhere. So integral 0 to x f of t dt equals, and I'll just do it on the fly, 3x minus x squared, because the 2's cancel, plus x to the third over 2 minus 23 over 48 x to the fourth, and that's h of x. I really should have put that in there. H of x equals, and then they say use that to approximate h of 1. 3 minus 1 plus 1 half minus 23 48ths. Using the magic of algebra, I was able to determine that that would get you 97 48ths. And now part D, you already know, you do not have to do for the 2020 exam, But as I keep saying, since the 2020 exam is not the only one that these videos might be used for, how do you find the error bound? Read it carefully. It says converges, individual terms alternate. So they're saying, hey, use the alternating series test. And part C, which is nice, they kind of tell you part 3, how far off is this? So I just go to the next term, which is a little tricky. I got to go all the way back up and find it. So I need to find the integral, absolute value, of fourth derivative at 0, x to the fourth over 4 factorial dx, which is, I believe, 54 x to the fifth over no, I just plug it in. Alright, hang on. I was going to say that doesn't look right. Didn't even I forgot to put my other absolute value on there. So I'll leave it like this for now. 54 x to the fourth, 4 times 3 times 2. By the way, you could just blast it out the other way too. And we get some nice cancellation here. 9, I think. So we integrate 9x to the fifth over 5 times 4. We plug in x equals 1 to find out what the mistake is, and we get 9 over 20. So we say the error bound for P4 of x less than or equal to 9 over 20, which shockingly enough is 0.45. I sure hope these things are getting at least recognizable. I hate to use the word easier. A lot of people are really struggling with these, and you've had a lot of practice. I'm doing all I can to help you out. Good luck, and good luck on the exam.